Hello students, welcome to your video lesson 9.3. In this video we're going to talk about both the Pythagorean theorem and the converse of the Pythagorean theorem, which just means the backwards version of it. So a couple different applications of the Pythagorean theorem, and the reason that we're doing this now is because this is an application of all this stuff we've been talking about with square roots. Earlier in section 9.1, we were talking about square roots. The Pythagorean theorem is an application of that. Just one thing that I want to get out of the way before we start. In this video, in this section, because we're dealing with something where we're talking about side lengths, like how long is the side of a triangle, we are not going to deal with negative square roots. Okay, so when we take a square root in this section, simply because we're talking about something that has length, we're not going to deal with the negative version, okay? We're just going to do positive square roots in this section. But before we get into the Pythagorean theorem, just want to go over a little bit of vocabulary with you. The Pythagorean theorem is something that applies only to right triangles, okay? And by right triangles, we mean triangles with a 90-degree angle. That's always marked for us in the triangle with this little box in the corner. That tells me that angle there is 90 degrees. And then we have a little bit of vocabulary for the sides of that right triangle. The side that is all the way across from the 90-degree angle is called the hypotenuse. And then the other two sides that together make that 90-degree angle are called the legs of the right triangle, okay? So a right triangle has two legs and one hypotenuse, and the hypotenuse is always across from that 90-degree angle, all right? Now, when we move into the Pythagorean theorem, we replace these vocabulary words on our sides with letters, okay, with variables. And normally we talk about our legs being A and B. Okay, so I have leg A, I have leg B, and then the hypotenuse is letter C. Okay, we just go A, B, C like that. So we have A, B, and C. And then the Pythagorean theorem is a formula that relates those three side lengths in the right triangle for us. Okay, and what the Pythagorean theorem formula says is that A squared plus B squared is equal to C squared. I'll put the squareds in there in just a second. Okay, A squared plus B squared equals C squared. I'm going to do it this way. Do that. Make it a little bigger. There you go. A squared plus B squared equals C squared. Okay, this is the Pythagorean theorem formula. Please make sure that this gets written down somewhere. And what this formula allows us to do is, if we know two sides of a right triangle, it allows us to find the length of the third side. And that's our application of square roots, which I'll show you in just a second. It also allows us to look at a triangle that we don't necessarily know is a right triangle, and using its three side lengths, it allows us to check and see if that is indeed a right triangle. So we'll go over both of those applications here today. So let's say, for example, in this right triangle here, A, B, and C, I know that A is 3 inches long, and I know that B here is 4 inches long. Knowing that information, even if C is unknown, we don't know what that is, we can figure out that third length, okay? That hypotenuse length in this case. We do that by just replacing what we know in our formula. Our A number becomes 3, our B number becomes 4, and then we just try to do some math and figure out what this C number has to be, okay? So what I end up doing here is A is 3, so this becomes 3 squared, plus B I know is 4, so that becomes 4 squared. And that's equal to C squared, which I don't know yet, so I'm just going to leave it as a C squared right now. Okay, C squared. So now I can start to do some math over on this side here, right? 3 squared plus 4 squared, we can do that math, and we can actually figure out what that whole side of the equation equals. Remember that squaring a number is just like multiplying it by itself again. So 3 squared is like doing 3 times another 3. 3 times 3 is 9. And then 4 squared is like doing 4 times another 4, and that makes 16. Okay, so now I know that 9 plus 16 is equal to c squared. Okay, if I keep going, 9 plus 16, that's something we can do. 9 plus 16 makes 25. And that's still equal to c squared. I have not changed that side of my equation at all, right? But now I need to figure out what c is equal to. I know what c squared is. I just figured that out by doing this math, right? C squared is 25. But I really want to know, what does c equal, not what does c squared equal. So the question is, how do I undo that squared, right? How do I undo squaring something? Well, to undo squaring something, we square root something. And square rooting, which is what we've been dealing with earlier in section 9.1, like I said, square rooting is the opposite of something squared. So if I do the square root of this number 25, that is going to unsquare my variable c, and it's just going to tell me what c is. Okay? So when I square root that 25, the squared piece goes away. Okay? So now the only question is, well, we know that c, whatever this length is, however long this side of the triangle is, it's equal to the square root of 25. So the question is, what is the square root of 25? And like I said, this is where we're not going to do both positive and negative options, because that side of the triangle can't be a negative number. So we just go back to before we even knew there were negative square roots, and we think about, okay, 25 is in my list of perfect square numbers, right? And 25 is equal to 5 times 5. So the square root of 25 is 5. Okay, so c is equal to 5. C is equal to 5. So this length here on this triangle is 5. Now, it's not always going to work out this nicely. And when we don't have a nice square root, I want you to remember we can use a calculator. We can round it off to maybe the nearest hundredth, 2 decimal places. And we can give decimal approximations for unknown values, okay? So that's how it works to find a hypotenuse length. Okay, that's one application of the Pythagorean theorem. Another option, if I just, let's see, that for a second. If I just do this, and then I can do a bunch of erasing. All right, let's go back. And now I want you to imagine that we know some other information. What if we knew that the hypotenuse length, this c value, was, let's say, 13 inches or feet or miles or whatever. And we knew that this b number over here, this b value, by the way, a and b totally interchangeable. Okay, the 2 legs of the right triangle, doesn't matter which one's which. Let's say we knew that the b value was 5 inches this time, and we wanted to find out the a value. Okay, we didn't know the a value. So now recognize that I know some different information here, but I'm still going to plug them into my Pythagorean theorem formula, just like I did the last one. Except this time my a squared is going to stay exactly the way it is. Right? It's going to stay a squared because I don't know what the a value is. I don't know the length of that side right now. But I do know the length of the b side. That's 5 squared. And then the length of the c side is 13 squared. Okay? Now, again, there's some math here that I can start to do. I'm going to erase more of this stuff down here. So I see 2 numbers that are being squared, and I know what those are equal to, or I can at least figure out what they're equal to, potentially using my calculator. 5 squared, we just went over just a second ago. That's 25, right? 5 times another 5 is 25. And 13 squared, 13 times another 13, we could use our calculator if we need to, but 13 squared or 13 times 13 is 169. So I end up with this right here, okay? I end up with this. And now, this sort of looks like an algebra equation that we were solving, back in chapter 3, 4, 5, 6, something like that. And we're going to try to do similar things here. Remember, our end goal is to figure out what does the A equal, right? So my end goal is to figure out A equals something. So the first thing that I want to get rid of and I want to remove is this plus 25 right here. I don't want to see a plus 25 attached to my variable A anymore because I want the A to be by itself. So I'm going to get rid of the plus 25. And this is where we need to remember back to our solving equations. When we're trying to get rid of something, what do we have to do? We have to do the opposite, right? We have to do the opposite of that. So instead of plus 25 here, this is going to be minus 25. Right? And that'll cancel out my 25. Of course, I need to do it on the other side as well. That's where the minus 25 goes over to the other side. And I end up with now, on this side, it just says A squared because the 25 is gone. And it's now equal to 169 minus 25. If I do that math, I end up with 144. Okay, so I end up with A squared equals 144. I'll erase just this last part right down here. A squared equals 144, and now I'm close, right? I know what the A squared is, but I don't really want to know what A squared is. I want to know what does A equal, right? Remember, this is my end goal. A equals, okay? And again, we see that I need to unsquare this variable A. So the question is, how do we unsquare something? Well, we just square root it. Okay, square root is the opposite of squaring something. So this A is going to equal whatever the square root of this number is. The square root of this number, square root of 144. Okay, square root of 144. And if we do the square root of 144 on a calculator, because that is a little bit bigger than what was in our list, but we should find that the square root of 144 is 12. Okay, and remember, we're neglecting the negative 12 option that we know exists because we're talking about the side length of a triangle, okay? So again, we end our Pythagorean theorem formula with this application of square rooting things, okay? But there is some equation stuff going on here as well. Okay, we have a formula. We plug some numbers into a formula, right? And now we're just trying to do math and solve equations and get to here. And when we get to the A squared part or the B squared or the C squared, we just have to remember that we square root both sides or square root that number. We will arrive at our answer, okay? All right. We have one more application of this Pythagorean theorem to look at, and that is taking a triangle, let's say this triangle, that we don't know yet is a right triangle. Okay, there's nothing marked in here that tells us this angle is 90 degrees, but we have some side lengths, okay? We know the side lengths of the triangle. Let's say that we know this side right here is 6 inches. We know that this side here is 8 inches. And we know that this side here is 10 inches. Okay, so we know the sides of the triangle are 6, 8, and 10. The question is this a right triangle? Is this a right triangle? Okay, is it a right triangle? Well, we can answer that question with the Pythagorean theorem. Okay, to do that, we just plug values in for each of our 3 variables, A, B, and C. Again, as I mentioned, the 2 legs, which are the 2 shorter sides, okay, the 2 shortest sides would be A and B, and it doesn't matter which order you do them in, okay? I usually start with the smallest one just so that I have a routine, but it doesn't matter. You can do the 2 shorter sides, A and B, in either order, and then the longest side has to be the C value. Okay, so what we're going to check and see is if I do 6 squared plus 8 squared, is that equal to 10 squared? Okay, so this is a big question mark right now. We don't actually know. It might be equal or it might not be equal, okay? So this is just a matter of us doing math, okay, on both sides. We don't actually have to square root anything here, but we certainly could. What I'm going to do is I'm going to start by squaring all of my numbers, okay? And I'm just going to say 6 squared, 6 times 6, that's 36. And then plus 8 squared, or 8 times 8, that's 64. And the question is that equal to, I'm not sure yet, but maybe that's equal to 10 squared, or 10 times 10 is 100. So if I add together 36 plus 64, do I get 100? 36 plus 64, do I get 100? The answer is yes, I do get 100. These are equal to each other. 6 squared plus 8 squared does equal 10 squared. So is this a right triangle? Yes, it is. It is because the side lengths fit the Pythagorean theorem. And if the side lengths fit the Pythagorean theorem, the triangle must be a right triangle. So once I know this, I say yes. I can say this angle right down here between my two shorter sides has to be my right triangle, my right angle. And that will answer the question, is that thing a right triangle? Now, if you were to add these two numbers together and it does not equal 100, okay, or it doesn't equal whatever the other side is, then we just say, no, this is not a right triangle. It's some other kind of triangle, and there's nothing that we can do about it, okay? So these are simple yes-no questions, but they are applications of the Pythagorean theorem. We plug our side lengths into that Pythagorean theorem formula, and we decide, is that true or is it not true? All right, if you have questions about the Pythagorean theorem, how to find missing side lengths, or determine if something is a right triangle, please reach out to me somehow, email, phone, or Zoom office hours. Otherwise, that's all I have for you. We'll talk to you soon.